So this is a review of Unit 3 and going into Unit 4 with the first chapter of Stoichiometry. So at the end of Unit 3, we learned about 3 different types of conversion factors. Using water as an example, one was the molar mass. 1 mole of oxygen, 1 mole of water weighs about 18 grams. So that includes the mass of 2 moles of oxygen, 2 moles of hydrogen and 1 mole of oxygen. We also looked at conversion factors coming from the chemical formula. For example, 1 mole of water would contain 2 moles of hydrogen. It would also contain 1 mole of oxygen. And then finally we used Avogadro's number. We also use Avogadro's number in Unit 2. So now we look at the stoichiometric conversion factor. So everything in a balanced reaction is a direct proportion, and everything can be used as a conversion factor. So for example, 2 molecules of hydrogen would give us 2 molecules of water. 2 moles of hydrogen would give us 2 moles of water. If we had only 1 mole of hydrogen, we could expect to get only 1 mole of water. Of course, this is assuming there's enough oxygen to make this reaction happen. 1 mole of oxygen would give us 2 moles of water. 2 moles of hydrogen would also evolve 572 kilojoules of energy. Consuming 1 mole of hydrogen would give us about half that much. So if you look at oxygen, 1 mole of oxygen would also give 572 kilojoules if there were enough hydrogen around. So you can see that this is all a direct proportion. And of course, 0 moles of hydrogen, we would get 0 energy. So here's a typical problem. How many moles of water can be made from 4 moles of oxygen? So like we've done throughout the entire semester, this is the number that we start with. It has only 1 unit in it. So we've got 4 moles of oxygen, and we know it's a direct proportion, and we want to convert moles of oxygen into moles of water. So that defines what has to go in here. I have to have moles of oxygen to cancel out, and I have to have moles of hydrogen to keep moles of water to keep moles of water in my answer. So where do I get the numbers for this? Right through the balanced chemical reaction. So there's a 2 in front of the water, a 1 in front of the oxygen. So how much heat is given off when 4 moles of hydrogen are consumed? So again, I start with 4 moles of hydrogen, and I need to get rid of moles of hydrogen and keep kilojoules. So what's in front of hydrogen is a 2. What's in front of kilojoules is 572. So these right here are stoichiometric conversion factors, and we treat them just like we've done throughout the entire semester. Now, is heat given off or is it taken up? Well, we can see that heat is a product of the reaction, so therefore it's given off, and this is an exothermic reaction. What about mass now? So molecules react with each other. They don't think about how much they weigh, and the masses in a balanced reaction are still direct proportions, but you can't use stoichiometric conversions with mass because we don't really want to combine steps. So we'll separate the steps. So as we talked in the chapter, here's what goes on in a chemical reaction. This works for moles and molecules. Outside in our world, we can't look at moles and molecules. We have to weigh things, so we use grams. And to get from our world into their world, the conversion factor to get between grams and moles is, amazingly, the molar mass. So I provided the molar masses over here, and this is what you learned how to calculate in Unit 2. So let's look at a problem. How many grams of water are made when 100 grams of oxygen are consumed? So right now, we're out here, grams of oxygen. We need to get into here, which is moles of oxygen. So that conversion factor is the molar mass. So again, I got grams of oxygen. I want to get rid of grams of oxygen. I want to keep moles of oxygen, so that would be my answer. And this happens to be the molar mass. So for every 1 mole of oxygen, it weighs 32 grams. Next, we need to convert moles of oxygen into moles of water using the stoichiometric conversion factor. So I got that many moles of oxygen. I need to get rid of moles of oxygen, keep moles of water to get moles of water in my answer. Now, where do I get these numbers? Right from the balanced reaction. So there's a 1 in front of oxygen and a 2 in front of water. So there's my intermediate answer. I now have 6.25 moles of water. The question is asking for how many grams of water are there. So what we need to do is convert moles of water into grams of water. You see, we would have to have moles of water down here to cancel out grams of water up here. This obviously turns out to be the molar mass. So there's our final answer right there. So with these kind of conversion factors, this is the hardest, going from the mass of one thing into the mass of another thing. And at the very most, you will have to use 3 different conversion factors. The order at which you use these, of course, is dependent upon looking at the units. So here's another problem. How much heat is evolved or absorbed when 100 grams of hydrogen is consumed? So I have to start with 100 grams of hydrogen. And if I don't know anything about what I'm going to do, what's the first thing that you would do? According to the end of that diagram on end of unit 2, we would look at going into moles. So again, looking at it in this context, here we are, grams of hydrogen. We need to get into the moles of hydrogen so that we can use the conversion factors in here, which are the stoichiometric conversion factors. So I converted grams of hydrogen into moles of hydrogen using the molar mass of hydrogen. And then I have 49.6 moles of hydrogen. I need to get that into kilojoules. So I have to cancel out moles of hydrogen and keep kilojoules. So where do I get these numbers? I go directly to the balanced equation. There's a 2 in front of the hydrogen, a 572 in front of the kilojoules, so that gives me my stoichiometric conversion factors. And here is my final answer. And then, how much heat is evolved or absorbed? Well, heat is evolved, which means it's given off because it's a product, and therefore this is an exothermic reaction.